In this lesson, we are going to revise some questions from Science Paper 2 of 2016 internal. Now here we are just going to look at section B. The diagram below shows how the molecules are arranged in three states of matter: solid, liquid, and gas. So matter consists of particles, and the only difference in terms of the three states of matter is how the particles are arranged. So let's look at the first part here. We can see that the particles are closely packed, hence there are no spaces. So this type of states of matter is a solid. Then for the second one, we can see that the particles are closely packed, but there is a space remaining above. So this is how a liquid can be drawn also. Then we have where the particles are sparsely packed and fill the entire container. Now we can go to the first question. Question A: state the name given to the change of state labeled A. So let's look at labeled A. Labeled A, we are looking at the change from a liquid into a gas. So when a liquid such as water is heated, it starts to evaporate or changes into a gaseous state. So this change is known as evaporation. Then for the second one, here we can see B. B, we are looking at, we have a liquid, but this time a liquid changes into a solid, where if you put water in a fridge, after some time that changes into an ice, which is a solid. So this is solidification or freezing. Okay, now question B: describe the movement of molecules in a gas. So for a gas like this one, we can see that we have some spaces, and the characteristics of the particles under a gas, the particles are smaller than the spaces between them. So therefore, the particles are free to move. So you can say the molecules are free to move. Due to large spaces between them. Okay, so now we can move on to question C. Which of the changes A, B, or C is endothermic? Now for we have endothermic. So the word endo means inside. We are looking at the reaction or change of state of matter where heat is absorbed or added for it to occur. Then if we look at exo, it's outside. So exothermic type of reaction, this one releases heat to the environment. So we are looking at releasing, or where heat is given to the environment. So now, if you are dealing with the states of matter, we have the solid, then it changes into a liquid. Then we also have a gas. So what you have to know is for a substance to melt, heat must be added. So melting is an endothermic reaction. Then for evaporation, you need to heat also. So evaporation is also endothermic. Then for a substance to sublimize, also we are looking at this as endothermic reaction. So melting, evaporation, and sublimation are all examples of endothermic reaction. Now the reverse represents the exothermic reaction, such as for a substance to undergo condensation, it has to be cooled. And if you cool a substance, you are giving heat to the environment. Then also for a substance to undergo freezing, it has to be cooled also. Then the other one is deposition. Deposition also consists or happens when a substance is cooled. So the three below here, these are exothermic type of reactions or processes. Then the above are endothermic type of processes. So therefore, from the diagram, we can see that process A is an endothermic reaction. So change of state of matter A. So we can see heat is added. So that's the reason why we are saying the above is endothermic. For a substance to undergo evaporation, it has to be heated. Now let's move on. Let's go to question 2. Question 2, the table below shows some apparatus used in the laboratory. The first one, we have separating funnel, Liebig condenser, pipette, desiccator, volumetric flask, laboratory thermometer, evaporating dish, Bunsen burner, and burette. Now the first question is, we are trying to find the apparatus that can be used for burning and heating. So from the diagram here, we can see that we have a Bunsen burner. Now for question B, preparation of a standard molar solution. So if we want to prepare a standard molar solution, we can use a pipette or volumetric flask. Then for question C, obtaining a distillate from a vapor of a liquid. So this, such as fractional distillation, we can use Liebig condenser. Then drying substances or keeping them free from moisture. So we have desiccator. So this one can be used to dry a substance or keep a substance from having moisture. Then measuring exactly 25.0 cubic centimeters of solution, so volumetric flask. Okay, now let's move on to question 3. So question 3, given below is a list of substances: aluminium, nitrogen, cement, potassium chloride, bronze, water, methanol, and seawater. So which substance is an element? So from the given table, we can see that an element, we have aluminium, then also nitrogen. So an element is just a pure substance that consists of only one type of an atom. Then let's look at question B. Which substance is a single compound? Which substance is a single compound? So for a single compound here, so water, then which substance is a mixture? So a mixture, we have, okay, bronze is a mixture because it consists of two metals, so it's an alloy. The root substance is an element that conducts electricity. So elements that conduct electricity are metals. So from the table, aluminium is a metal. And conductivity of electricity is one of the characteristics associated with metals. Now from the table from the table above list, select one ionic compound. An ionic compound is a compound that consists of a metal and a non-metal. So if we can see potassium chloride, potassium is a metal from group 1, then chlorine is a non-metal from group 7 element. So we can see that potassium chloride is an ionic compound. Then we have an alloy bronze. Okay, now let's move on to question 4. Question 4a, explain what is meant by limiting a reactant. So during a chemical reaction, you may have a chemical reaction that consists of maybe a reactant that is in excess and one that is insufficient. So the one that is insufficient will be used up first before the other one is finished. So the substance that is used up first before the other one is done is what we call a limiting reactant, because it limits the amount of product that will be produced. So we can say a limiting reactant is a reactant that is used up during the chemical reaction. So the one that will be used up first before the other one is done is what we call limiting reactant. Now for question B, 2.4 grams of magnesium reacts with 0.30 moles of hydrochloric acid. Write the balanced chemical equation for the reaction. So here we are looking at the reaction between a metal. So a metal here is magnesium. So when a metal reacts with an acid such as hydrochloric acid, we are going to get salt. So our salt this time, a salt is an ionic compound that consists of a metal and a non-metal from the acid, so magnesium. So from the hydrochloric acid we get the chloride, so becomes sodium chloride plus the hydrogen gas. So that's a pattern when a metal reacts with an acid, so salt and hydrogen must be produced. So here we can now say we have Mg, magnesium solid, plus H. So HCl aqueous. Then we are going to get magnesium. Now for magnesium, Mg has a valence of 2, chlorine has a valence of, so if we use the cross kind of format, we are going to get a magnesium chloride such as this plus hydrogen. So hydrogen is a diatomic gas and must have a 2. Now after we are done with writing our chemical equation, we need to balance. So let's check from the reactant party. From the reactant party, we can see that we have one chlorine atom, but on the product part here, we can see that we have 2. So now we need to have a 2, so we put 2 in front of HCl so that we have 2 atoms of chlorine, also 2 atoms of chlorine on the product side. So this also 2 is affecting the hydrogen, so we have 2 atoms of hydrogen, also 2 atoms of the hydrogen here. So you can see that now our equation is balanced. Now for question 2, determine the limiting reactant. So we want to know between magnesium and hydrochloric acid which one was used up first. So the first step that you need to take whenever you are looking at the limiting reactant, you need to find the number of moles for each reactant. Now for hydrochloric acid, we have been given the number of moles, so let's just find the number of moles for magnesium. So we can now say number of moles is equal to mass divided by molar mass. So the mass for magnesium is given 2.4. Then the mass number for magnesium is 24. So here we are going to get 2.4 over 24. So if you punch this on the calculator, you are going to get 0.1. So we have 0.1 as the number of moles for Mg. Now, so after finding the number of moles for each reactant, we need to divide by the mole ratio. So what we are going to do is this one. So let's look at the magnesium here. I'll write it here. Then we have HCl here. So the number of moles for magnesium is 0.1. Then to the number of moles for HCl, the given is 0.3. So now we need to divide by each mole ratio. So the mole ratio is the number in front of the reactant. So the number in front of magnesium, since it's not shown, it's 1. Then the number in front of HCl is 2. So if we divide 0.1 divided by 1 is 0.1 moles. Then let's divide the 0.3 divided by 2. This should give us 0.15. 0.15. So now after finding the mole ratios, after dividing the mole ratios for each reactant, we need to compare. So the one with the lowest number in terms of the mole is the limiting. So you can see that 0.1 is less than 0.15. So therefore, magnesium is the limiting reactant. So the answer here is magnesium. Okay, now we can move on to calculate the mass in excess for the substance which is in excess. So the substance that is in excess is hydrochloric acid because it has the mole. So now let's find the mass. So we are looking at, so let's find the mass is equal to number of moles multiplied by molar mass. So let's now do compare. So if we subtract 0.15 minus 0.1, we get 0.05. So 0.05 represents the number of moles that remained unused. So this is the one that we are going to substitute where this, and since we are calculating the mass in excess, so the mass that was not used. So 0.05. How I've calculated this number is by subtracting, since I know that 0.1 for mg represents the number of moles that were used. So from 0.15, 0.1 was used, so 0.05 remained unused. Then let's find the molar mass for HCl. So HCl, there is one atom of hydrogen and one atom of chlorine. So it's hydrogen times 1 plus Cl times 1. So the mass number for hydrogen is 1 plus 35.5 times 1 is 35.5. So the molar mass is 36.5. So if we now calculate 0.05 times 36.5, we get 1.825. So this is the mass of HCl that was in excess. Okay, now from there, let's now move on to question 5. Question 5, 20 grams of marble chips were reacted with 50 cubic centimeters of 3.0 molarity hydrochloric acid. So the total volume of a gas obtained was recorded at various time interval, and results were tabulated as shown in the table below. So we are looking at the graph. So plot a graph of volume of carbon dioxide against time. So here the volume should be in the y-axis, then the time should be in the x-axis. So here we have a 0. Now this, the way science graphs comes is we are expected to make our own graph. So let's make our own graph. So here we can see, so 15, then the second one 45, then we have 60. Okay, so let's just use the 30, 60, so we just use 2 centimeters to represent 30 units in x-axis. So under our y-axis we have so let's see, the graph is not that clear. So we just use 2 centimeters to represent 20 units to 20, 40. Then we have 60 here. So now we can let's plot. So 0,0 is here. Now 15,40, so the 15 is half of 0 and 30, so 15,40 somewhere here. So as you are revising, please, you can use the actual graph paper so that you can get everything okay. Then the second one 45 is between 30 and 60, then 56 somewhere here. Then we have 60, 60, then 75, 60, 90, 60. So now let's draw our graph. So it's something like this. So that is how a graph should be. Now, from the graph, we can see that as time proceeded, the volume of gas produced started to reduce until it remained constant. So you can see that we have a 60 cubic centimeter at 60 seconds, 60 at 75. So the time kept on elapsing while the volume of carbon dioxide remained constant. Now let's look at the first equation B. 1. Work out the rate of production of the gas at 30 seconds and 50 seconds. So rate is equal to change, in our case, so change in volume divided by change in time. So the change in 30 seconds, so it's 30 seconds over volume. Let's look at so 30 seconds, how much of the volume was produced at 30 seconds? So 30 seconds, approximately 50 cubic centimeters. So let's divide 50 divided by 30. We have 1.6, so which is 1.7 cubic centimeter per second. Now let's look at another rate. So the other one, where the time is 50 seconds. So when the time is 50 seconds, approximately 58. So 58 divided by 50. So here we get 1.2 cubic centimeter per second. So we can see from the rate of the reaction, at first the reaction at 30 seconds the reaction was about 1.7 cubic centimeter was produced per second. Then as the reaction proceeded, the production rate reduced to 1.2 until it came to 0. So what do you conclude about the rate of reaction as time progressed? So as time progressed, the conclusion is the rate of reaction started to slow down until it stopped. Now, how can you know that the reaction is stopped? When the graph here, at this point, when the graph here becomes a straight line and parallel to the x-axis, or as we can see from the table also, here we have 60 and also here 60, then also 60. So you can see that the volume stopped changing, therefore giving us a picture that the reaction stopped to occur. Okay, now let's move on to question 6. Question 6 is, what do you understand by each of the following? Any hydrous salt. So this is a type of salt which has no water molecules inside it. So we can say this is a type of salt with no water molecules trapped inside. Then the other one, an efflorescent substance is a substance which has water molecules and when exposed to air, the water will evaporate. Okay, now let's move on to B. Give an example of the following: an efflorescent substance. So an example of this one, we have magnesium sulfate, then also including washing soda. Then for a deliquescent substance, we have sodium chloride as an example. Sulfuric acid also. Okay, so now let's move on to question 7. So question 7, we are looking at some questions from a periodic table where bodium BO is a newly discovered element. So now characteristic, it is a solid at room temperature and pressure. Then the other characteristic, it can be cut with a knife, react vigorously with water, liberating a flammable gas and forming a solution with a high pH. So number 1, metals with characteristics such as that can be cut with a knife, group 1 and 2. Then also high solid at room temperature and pressure, group 1 and 2. Then the other key is reacting vigorously with water. So the only metals that behaves like this are those from group 1. When a group 1 element such as sodium, potassium react with water, it produces a solution with a high pH value or a base such as sodium hydroxide. So the first question is, to which group of the periodic table does bodium belong? So here we have group 1. Then write a balanced chemical equation for the reaction between bodium with water. So the way metals such as group 1, if a metal react with water, one of the properties, we are going to get metal hydroxide plus hydrogen. Such as if we have sodium plus water is equal to sodium hydroxide plus hydrogen. So this time is bodium plus water. So bodium plus water is equal to bodium hydroxide plus hydrogen. Okay, now let's convert into symbols. So the first one here, we have bodium BO solid plus water H2O liquid. Now the bodium BO, since we are saying it is from group 1, it has a valence of 1. Hydroxide OH has a valence of 1. So therefore this will give us bodium hydroxide will be like this. So we have bodium hydroxide aqueous plus hydrogen diatomic. So we are told to write a balanced chemical equation. So the balanced chemical equation, okay, we can, so let's see, let's balance first the hydrogen. So here we have 2 times 2 is 4. So we can also put 2 in front so that we have, here we can see that we have 2 hydrogen plus 2 hydrogen. So hydrogen 4. Then oxygen, here we can see that we have 2. Also here we have 2. Then we only need a 2 in front of BO. So this is a balanced chemical reaction. Now question B, state whether you would expect bodium carbonate to decompose on heating. Give a reason for your answer. So if this bodium was to be bodium carbonate, when heated, would you expect this substance to decompose or not to decompose? So bodium carbonate cannot decompose to heating. Why? Since bodium is being compared to group 1, carbonates of group 1 elements does not decompose when heated because they are considered to be stable. So it cannot decompose. So carbonates of group 1 or metals from group 1 elements are considered to be stable when it comes to heating, so they do not decompose. Now let's look at the question 8 here. Now question 8, the diagram below shows the setup of the apparatus that would be used to prepare gas X. So from the table we can see that we have hydrogen peroxide, then also manganese oxide, then we have the gas jar and gas X. So Roman number 1, the first question, identify gas X. So since we are dealing with hydrogen peroxide, the gas that we prepare from hydrogen peroxide is oxygen. So you just have to have that in mind. Then for Roman number 2, describe the chemical identity test for oxygen. So it relights a glowing splint. Then, what is the purpose of adding manganese 4 oxide to hydrogen peroxide? To speed up the chemical reaction. or if you want to, we are just saying it is acting as a catalyst. Then explain why this gas is obtained using the method shown in the diagram. So you can see that this is an downward displacement of water because it is less soluble in water. Then let's look at for the last question. Now the last question here, we are dealing with a question from organic chemistry. The table below shows some information on two polymers. Then the first polymer, polyvinyl chloride, PVC. Then the type of a polymer. So polyvinyl chloride, PVC, or polychloroethene can be formed by addition of monomers. So this is addition polymer. Then for C, this one we have an esterification, linkage type of linkage, this one, a COO, so this one is condensation polymer. Now, what is the best method of disposing of polyvinyl and polymer B? So these substances are non-biodegradable, so the best and safest way of disposing is by recycling. Now, name the products of protein hydrolysis. So the end products of protein hydrolysis are amino acids. Okay, and that's it for this video. Thanks for watching, and don't forget to subscribe, share the video,